Welcome back to the Trigonometry Midterm Review. This video will focus on Chapter 2 questions that I've selected from the even problems that I assigned. In number 10, they talk about right triangle ABC, and they give some specifics about that. It's very good to draw the picture when there is no picture, and so that's what I've done here for you. The first thing we have to do is find the opposite side to C, which is little c. Remember, a lowercase a means that side opposite angle A is 3 units, and the side opposite angle B is the square root of 7 units. So we've got to find little c. Little c squared equals 3 squared plus the square root of 7 squared, and that will be 7 plus 9 is c squared, or 16 equals c squared. Take the square root of both sides, and you find that the side length for c is 4 units. With that information, now we can find the 6 trig functions of angle A. Because that's the angle that we're going to be talking about, I like to circle it. And now I typically write the trig functions in the same order. So sine, cosine, tangent, and then their reciprocal functions, cosecant, secant, and cotangent. Sine from A, we remember, is opposite 3 over the hypotenuse. So the sine is 3/4. That, of course, is opposite and adjacent. When we talk about those with the trig functions, we are talking about the relationship of the side to the angle in question. So here we're talking about angle A, so side CB would be the opposite, side AC is the adjacent, and the hypotenuse is always across from the 90-degree angle. The cosine now is the adjacent over the hypotenuse, or the square root of 7 over 4. And the tangent is what we get when we divide sine by cosine. Since the denominators are the same, they will divide out, and we will get the tangent to be 3 over the square root of 7. A radical in the denominator is just bad practice in mathematics, so we rationalize by multiplying the square root of 7 over the square root of 7, which equals 1. So we're not changing the value of the expression, just its appearance. And 3 square roots of 7 over 7 is the better answer here for tangent. There's our cosine and our sine. Cosecant is the reciprocal of sine, so just 4/3. Secant is the reciprocal of cosine, and so 4 over the square root of 7, which again we need to rationalize, so we multiply by the square root of 7 over the square root of 7, and you will have 4 root 7 over 7 as the best answer for secant. And now cotangent A is the reciprocal of tangent. Going back to this first part, not the already rationalized part, where we would create more work if we used what was in the circle. But here, in this piece, the square root of 7 over 3 is the better way to go there. So there's all 6 trig functions at angle A in this problem. (42) and 44, we're kind of working side by side here. For each of these, they want us to simplify the expression after we substitute the values from the exact values table. The exact values table that they're referencing is found on page 60, table 2, and yeah, that's where you'll get everything that you need for this problems, or these problems. Sine of 45 degrees is the square root of 2 over 2, and cosine of 45 degrees is the square root of 2 over 2. We're subtracting them and then squaring the answer. So the square root of 2 minus itself leaves us with 0, and 0 squared is 0. So the simplified answer to 42, in fact, is 0. Number 44, it's a little different in that the tangent at 45 degrees is 1, and the tangent at 60 degrees is the square root of 3. Each of those are going to be squared, so these values are different. It's not like we're adding or subtracting the same number like we did in 42. In 44, they're different. 1 squared is 1. The square root of 3 squared is 3, and 1 plus 3 is 4. Number 58, we're going to find the exact value of the cotangent of 30. Well, first, I know that tangent is the reciprocal of cotangent. So I know from the table that the tangent of 30 is the square root of 3 over 3. And so the cotangent is the reciprocal of that. Cotangent 30 degrees is going to be 3 divided by the square root of 3. Again, we rationalized this as we did in a few problems a moment ago by multiplying by 1. It's just special because it's the square root of 3 over square root of 3, so that in the denominator, the square root of 3 times the square root of 3 becomes the square root of 3 squared, or just 3. In the numerator, 3 times the square root of 3, and we see that we can simplify 3 divided by 3, leaving us with the cotangent of 30 degrees being the square root of 3. Find the exact value of the secant, or secant 0 degrees. Well, secant is 1 over cosine. So let's find first cosine at 0 degrees. And cosine at 0 degrees is 1. Where am I? There's the pen. And so secant of 0 degrees, that is going to be 1 over cosine, so 1 over 1, or still just 1. So secant 0 degrees is going to equal 1. Moving on to section 2, from chapter 2, we've got a few problems here dealing with degrees and minutes. So first, in number 8, it's just an addition problem, and I like to do this vertical addition. It just seems to work better for me. So I'm going to take 8 plus 2, that's 10, carry the 1. 5 and 3 plus 1 is 9. Now, 90 is larger than 60, and we know that 1 degree is 60 minutes. So if I have a total here of 9, I'm going to take out 60 and call that 1 degree, and the 30 is what's left over. So 30 minutes. 4 plus 3 and 1, 8, 6 and 2 is 8. So we have 88 degrees, 30 minutes. In number 12, I'm going to do this vertical again, but with the 90 instead, I'm going to write it as 89 degrees, 60 minutes, because again, 1 degree is 60 minutes, and we need that value there to subtract the 25 minutes from the next number here. So 60 minus 25 being 35 minutes. 89 minus 62 is 27 degrees. So these are the two answers there. Now for 48 and 52, they ask us to use a calculator to find tangent and secant in these problems. Well, that's okay. We got buttons in the calculator to do it. The problem is there's not a way to type in minutes. So we have to convert the minutes back to degrees. So first, to do that, I'm going to take the 45 minutes and multiply that by 1 over 60. Because a minute is 1/60th of a degree. And since I'm trying to get back to degrees, this is why we're doing that. So that's going to be 45 divided by 60, or 0.75. Meaning the question here is really asking us to type into the calculator the tangent of 19.75 degrees. Making sure that you are in the degree mode, you can go ahead and hit those buttons, and you're going to find 0.35903, and the numbers continue. In the problem, they ask us to round to 4 decimal places, and I've written 5 here. The 3 does not round the 0 up, so we can get rid of that 3. But I need to continue, or I need to keep that 0 in place because they wanted 4 decimal places, and so that 0 does occupy that 4th decimal place, and therefore we can't exclude it from our answer. In 52, the same thing. 48 minutes times 1/60th is going to equal 0.8. So I am asking to find the secant of 84.8 degrees. But there is not a button in the calculator for secant. We have to remember its reciprocal function, and instead remember that secant is 1 over cosine. So I'm going to say 1 divided by cosine 84.8 degrees, making sure that this is in parentheses under the fraction, and we will get an answer of 11.03355. Again, they want our answer rounded to 4 decimal places. So this 5 is going to change, the 5 is going to change the other to a 6, and 11.0336, 4 decimal places for the answer there to 52. Number 72, they want us to use a calculator to find theta, this time in the first quadrant, that satisfies this statement. Secant theta equals 1.0129. Write our answer in degrees and minutes. That's important, rounded to the nearest minute. Okay. Secant, again, is 1 over cosine. So 1 over cosine theta equals 1.0129. The same point, we can multiply both sides by cosine theta, and then we would divide by 1.0129 and end up with 1 over 1.0129 equals cosine theta, which is what we're able to do in the calculator. Now we're going to take cosine inverse of both sides to be able to find theta, and theta will equal in the calculator 9.15, and it continues with a bunch of digits. We're going to keep those digits in the calculator. Leave them alone, don't do anything. What I'd like you to do is now subtract 9 so that you have just the decimal. We know our answer is going to have 9 degrees, but we have to find out how many minutes. And so if you take now that decimal 0.15, etc., and multiply by 60, you're then going to get 9.24, etc., and it continues. All of those digits don't matter because they say round to the nearest minute, but since we did not round the decimal answer for theta until the end here, we know that this tenths place digit is the most accurate at 2. 2 is not going to round 9 up any higher, so we have 9 degrees from here, and then the 0.15 times 60 gave us 9 minutes. So theta is approximately 9 degrees 9 minutes. In 40, I see 45 degrees in a right triangle. Well, that means this other angle is 45 degrees. And in a 45, 45, 90 right triangle, both legs are the same. So this 2 units is the same 2 units here. To find angle A to the nearest degree, I notice that I have the opposite and the adjacent to angle A in this right triangle. So I can find tangent of A is opposite over adjacent. And we're going to take the tangent inverse of both sides of the equal sign and find that A is approximately 33.69 degrees. But they said round to the nearest degree, and therefore this 6 makes this 3 a 4. 34 degrees approximately for angle A. (46) You see 2 triangles. You see a black triangle and a red triangle down here on its side. The angle ABD, that's this angle in here, is 53 degrees, and they tell you that this angle C is 48 degrees, and that side BC is 42 units. First, we want to find X. So we're working in the red triangle here on its side, kind of on the bottom here, ABC. And I see that I'm given 48 degrees. We want to know the opposite, and we have the adjacent. So again, that's tangent. Tangent of 48 degrees equals X over 42. Multiply both sides of the equation by 42 to get X by itself. And X is going to be approximately 46.6457, and the numbers continue. Leave this answer in your calculator. For our purposes, we will say X equals 46.6 units, since they did not tell us how to round in the question. So that's X. But again, in the calculator, you're going to leave the big long number. You'll see why in a minute. Now we're going to look at the black triangle ABD that's sort of sticking up out of the page. We know side X now is about 46.6, and we're trying to find H. We're given angle 53. So again, we have the opposite side H and the adjacent side 46.6, blah, 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 blah. Tangent of 53 degrees equals H over that answer that you have in your calculator, which is what we're going to multiply both sides of the equation by. And we will have H equal to, in your calculator now, if you hit just the tangent button, it should take the previous answer unrounded, that 46.6457, etc. If it doesn't, hit clear, and then hit the times button, and then tangent 53 degrees, and it should pull that answer into the multiplication problem right away unrounded, so that our side length for H is the most accurate that it could be. And when you do that multiplication accurately, 61.9 rounded now to the nearest tenth to stay in line, or to keep in the same convention as what we did for side X. In our last question for this review video, I chose number 42. I could have also assigned problem number 41. So if you wanted to add 41, the answer's in the back. That's another one that could be beneficial to you. You'll notice this picture is similar to a quiz question, but not the quiz question was not a real-world problem. Here, we're going to apply that math to a real-world situation. In this figure, number 22 in your text goes with problem number 41. It's just to be an example of the picture that they're describing for this problem, number 42, where they're talking about an airplane, and excuse my art, here's our airplane that's flying above the Earth. And it says it's flying 4.55 miles above the Earth. Here's A, and here's point B, and here's the center of the Earth. It gives us a radius of 3,960 miles. And this would make a right angle here as this radius to the tangent line. Makes that right angle, and they first want us to find that side. What is the length or distance from the plane to the horizon? Okay, I'm going to get rid of that picture for just a moment. Okay, so I've moved some things around. Here's our picture now, and that gives us space to work to find x. I'm going to use the Pythagorean theorem here, as we have a right triangle, we know two sides and we need the third. But let's go ahead and add these two portions together to get the length of the side from A to the center of the Earth, which is 3,964 miles, well, 64 and 55 miles long. So we're going to have x squared plus 3,960 squared equals 3,964 and 55 squared. These numbers are going to be quite large, but they'll get nice and manageable here shortly. So first, x squared plus 15,600 equals 15,700. We're going to subtract this 15. And we'll have x squared equal to 36,056 and 7,025. Okay. Take the square root of both sides to find the length x, that distance we were looking for, and that's going to be approximately 182.886. They did not talk about how they want it rounded. We'll say x is 182.9 miles. But there was a second part to the question. They also want the measure of angle A. First, plane to the horizon, we just answered that, but now angle A. So to find angle A, we could use any side. I recommend not using the side that we just found because we rounded that answer. But this side was given from the beginning and this side was given from the beginning, so I'll use those. Working from angle A, we have the opposite and the hypotenuse, and sine is the trig function that involved the opposite over the hypotenuse. To find angle A, we take the sine inverse of both sides. And A is approximately 1.5 degrees. Hopefully this video was helpful for you in preparing for the Chapter 2 questions that you might find on the midterm.